Hello, everybody. Today, I would like to talk about digital image processing, which is a series of a master course lecture I used to give in the university and about digital image processing and related area. Okay. Um, let's start here. Uh, what is digital image? A digital image is a representation of a two-dimensional data or image as a finite set of digital values called picture element or pixels. Picture element or pixels. We have a scene element here, the illumination source here, energy, and then image grasping by a system or camera or whatever, and then internal image plane, and at last the output image, digital image, is shown here. Next. The pixel values typically represent gray levels. Usually it's gray levels. Or maybe it is colors or heights. Opticity. Opticity is blur. Much, for instance, a blur picture or a kind of not dark but blur somehow. Remember this, the digitization implies that the digital image is an approximation of real sense. So for instance, here is this, and then we make it bigger. For one pixel, small pixel is here. So these three kinds, the gray level, color, and heights, and opticity also. For instance, here, again, the common format is one sample here format, one sample format, which is black and white, gray level scale, like this. Or three sample per point is one sample per point is three sample. Three sample is red, green, and blue. Also, we have four sample per point per pixel, which is red, green, blue, and alpha. Alpha is the percentage of opticity, which is the blur, how much it is blur. But most in the course of this course, we focus on gray scale here, black and white. Okay. Digital image processing uh, focus on two major tasks. Improvement of pictorial information for human interpretation. So human want to find, and it's for human to get some information. It's for human watching or something. Another task is processing of image data for storage or transmission and representation for autonomous machine perception. So it is machine perception and for storage and transmission. It's not, human is not involved directly here. Rather, it's for machine perception and, well, maybe storage, transmission. Later, human, of course, will use it, but this is for this human perception. This is the machine perception. This is human perception interpretation. Some argument between where image processing ends and fields of such as image analysis and computer vision starts. So it depends to how what you think about. So I should divide this here. The continuum from image processing to computer vision can be broken into three levels. Low level, mid level, and high level, which is low level is like we have input image and the output is image. For instance, noise removal or image sharpening and so on. Kind of uh, cleaning image or something like that. Mid-level processing is input still is image, but output is attributes, some parameter attribute to the image. Example is object recognition and segmentation. For instance, this image is recognized like this and segmented like this. Very high level processing is input is attributes, also output is not is higher, is understanding, like human being understand this image contains a hand of a dog or hand of a cat, or this is a cat, this is a mm, head of a cat, or some other understanding. Or it is, for instance, a sen, or what kind of more sophisticated. Example, sen understandings, autonomous navigation, and so on. So it is more goes to the artificial intelligence. That we stop here in these two sections and in this course, and this is for higher course. Okay. This is just a history, and then I would first I tell about history of image processing, then I go to application in this first session. The history, it began in 1920s. One of first application of the digital image was the news paper industry. The Bartlane cable picture transmission service image were transferred by submarine cable between London and New York. Pictures were coded for cable I mean, by cable transfer and constructed at the receiving end on a telegraph printer, something very primitive. Late mid or to late 20 improvement to the both lane system result in higher quality image, new reproduction processing based on photographic techniques, increased number of the tone reproduces the image. This, for instance, this two image. This is 15 tone image. Next. 1960s improvement in computing technology and onset of the space race led to the surge of work in digital image processing. 1964, computer used to improve the quality of image of moon taken by Ranger 7 probe. Such techniques were used in other space missions, including Apollo landing. For instance, this is the picture of the moon taken by Ranger 7 probe minutes before landing. This. And in 1970s, digital image processing begins to be used in medical applications. 79, Sir Godfrey N. Hansfield and Professor Alan M. Cormack shared the Nobel Prize in Medicine for invention of tomography, the technology behind the computerized axial tomography CAT, or what we call it CT scan today. So this is typical head slice CAT or CT image like this. This two person got the Nobel Prize 1979. In 1980s and today, they used digital image processing technique as if exploded, and they are now used for all kind of tasks in all kind of area. Now I start the some application. For instance, image enhancement or restoration. It's not or, it's and restoration. For instance, enhancement is different, and I will later explain about what is enhancement, what is restoration. Artistic effects, medical visualization, industry inspection. For instance, you want to inspect a body of the airplane, or some cracks in some um, for instance, industrial something, plane or something, without destruction, without destroying it. Law enforcement, for instance, notes, bill notes, you can make a watermarking to make it from fraud or something like that. Human computer interface. This is the last, human computer interface. This is some example here. One of the most common used DIP, digital image processing technique, improve the quality, remove the noise and something. This is the first level, maybe. For instance, this is the X-ray of the chest that after high pass filter or maybe high boost or something like that, I will explain later. The bone are clear here, but not here. So the physician, doctor can recognize whether there is a fraction or something like that. In industry, this is the, for instance, a printed circuit. If there is something, so we can make it remove noise or remove noise removal and make it clean noise, clean picture. For instance, in pollution, this is pollution from this satellite or airborne picture, then pollution cannot see the very clean. After removal this pollution, then you get this picture. This application. On my background in this images here is the Hubble 1990 Hubble telescope can take image of very distant objects. However, an incorrect mirror, this mirror is incorrect. Then the Hubble image become blurred like this. By processing technique, we can fix it like this. So this is, and now after Hubble, we have new also telescope now today. And anyway, by mirror, incorrect mirror adjustment, you take this image, but you have to make it deblurring. Deblurring also is very complicated algorithm in image processing. Next. For instance, in cinema, in movie, or something like that, artistic effect, which is blue effect here, are used to make an image more visible, appealing to add a special effect and to make composite image. For instance, this is like here, a man like this, but the blue effect make this image to any background you want. For instance, my background here is, of course, this is different, but anyway, this is artistic effect. Also, this one, this example, SF, and also this example. Now you are very familiar with this kind of the by all kind of the new techniques today. Next, medical medicine. I mean medical application, take the slice from the MRI picture, I mean scan of the canine heart. Canine is dog heart, and find the boundaries between the type of tissue. Boundaries like this edge detection. Image with gray level representing tissue density and use suitable filter to highlight the edge. If you make the highlight here, maybe you can find any problem with the heart or something like that. This is a medical, it's very simple. Later we go to more complicated. Also in GIS, Geographic Information System, digital image processing techniques are used extensively to manipulate a satellite imagery, for instance, in train classification and meteorology. This is, for instance, in train classification or in meteorology. Is, for instance, a typhoon is here, you want to follow the where typhoon is and so on. So in GIS also has application. For instance, also in GIS, this is North America, this is South America, nighttime lights of the world data set global inventory of the human satellite. Not hard to imagine the kind of the analysis that might be done using this data. For instance, you can see the North America in the night and South America in the night. So how it is populated and with more light here and less light here, for instance. This is kind of just using human operator are expensive, slow, and unreliable. You can instead of human, you can give to machine, make machine do the job instead of human. Industry vision, for instance, here system are used to in all kind of the industry, here, or even here. This printed circuit, this is for molecular or chemical and so on. Also, printed circuit board inspection, printed circuit board, PCB, with machine inspection is used to determine all components are present, all component present, and all solder joint are acceptable. So with computer and machine can inspect this. In human, very difficult to recognize that, both for conventional image or X-ray image. Okay. Also for law enforcement, for instance, image processing technique are used for extensive by law enforcement number plate recognition for speed, cameras, automated toll system, fingerprint recognition, enhance of CCTV. This is fingerprint, this is a plate number. Even the plate number is taken from the oblique, from the corner. You can, yeah, I mean, recovery, what is the number, and so on by image processing algorithm, of course. This is much more difficult. I will explain if I have time. Also, here is a human-computer interface. They try to make human-computer more natural. For instance, for face recognition, gesture recognition, hand recognition, and so on. It's very important that today everybody uses. Also today they have many algorithms for this. Okay, here a key strategy for processing Here it shows the problem domain, image acquisition, image enhancement, for instance, or you want to do image restoration, or even morphological. Later, I will explain about this morphological processing or segmentation, object recognition, representation description, image compression, and color image processing. These are, I will give you some example in each domain. This is image acquisition, as I explained before here. This is image enhancements, how the grain here can enhance and get the better image. For restoration, for instance, in electronic camera, they have some noise, some kind of vertical horizontal line that you can remove it by harmony reduction technique or something like that in image restoration. It's not only this, but many kind of the noise also. For morphology, morphology is kind of the I mean two levels, 0, 1, black and white, and then by more mathematical, difficult mathematical, logical, I mean, Boolean algebra you can use for morphology processing. For instance, for fingerprint, which is broken line here, you can recognize a better fingerprint here. Segmentation, this is, for instance, a instrument like this. This is histogram. They make the histogram wider, then you get this shadow is removed, and then the real image is obtained. Of course, object recognition is kind of segmentation, so you can find where is the segmentation of the objects. Also, representation description, which is here, for instance, like this, and we will explain in detail later. Image compression, of course, you are familiar with this kind of thing, that image compression is useful, that you compress the data and then you can send or store it. Color image is very important. For instance, this is the photo of the phantom of the, for instance, long uh, for X-ray or something like that, then you make a false coloring. And with false coloring, you can determine where the point is, which gray level is attributed to that point. And then this is not real, but rather false coloring for image processing. This is another one. Okay, here I stop here. And for this session, next, in image DIP number 2, I will give you next. And thank you very much. This is a continue of the series of the digital image DIP lecture for master course. Thank you very much. I stop here.